Hello and welcome to the webinar presented by Biocoat. Topic for today's conversation will be evaluating and selecting a hydrophilic coating provider. And today we'll be covering suggestions, tips, and recommendations to support your project. My name is Jim Moran. I'm the president and CEO of Biocoat, and I'm joined today by Dr. Robert Hergenrother, or Bob Hergenrother, who is the Vice President of Research, Development, and Innovation at Biocoat. From a high-level perspective, Biocoat has been specializing in the development of hydrophilic coatings for 30 years. In fact, this is our 30th anniversary, specifically in the area of intravenous medical devices. We were founded in 1991 and we're privately held, and our ownership is 1315 Capital, a private equity group in Philadelphia. We're headquarters just outside of Philadelphia, Pennsylvania, in Horsham. We are an ISO 13485 2016 certified operations, and we have products that have been in use in over 160 countries around the world. From the time that I joined in 2018, we've made a lot of progress in our coatings and services we've been innovating for the last 4 years. In 2018, we opened a new 40,000 square foot facility, which houses all of our production, operations, and services. In 2019, we launched our first coating services business unit around thermal cure coatings. In addition, in the same year, we introduced a premix called HYDAC for thermal cure coatings, and that was released. And we got recertified by our 1345 2016 through ISO. In 2020, we continued to invest, and we developed our first HYDAC ultraviolet cure hydrophilic coating and launched that in 2020. And we continue to expand both our services and operations and products. In 2021, we expanded our coating services to include UV cure hydrophilic coating operations. We've also enhanced our process capabilities and are now able to hydrophilically coat films and added more services for you and your products by introducing plasma services into the Biocoat organization. In 2022, we will continue to innovate and grow as an organization, helping to meet your vertical needs as you're looking to develop and to launch new products by entering into agreements to develop unique machine services to help you to be able to coat your devices in-house. What we coat is really important as you look at your products. What you see here is that Biocoat has been coating in the neurovascular, cardiovascular, ophthalmic, and peripheral markets for the last 25 years. And more recently, we've added thin films and microfluidics to our overall capabilities. From a benefits perspective, HYDAC, which is our brand name for both our thermal cure and our UV cure, offers best-in-class performance in lubricity and durability, as well as particle counts, and Dr. Hergenroth will be talking about that today. Our coatings are extremely thin and flexible, utilizing a cross-linking chemistry. We're able to help you with multiple sterilization options for your products and offer easy integration. In addition, by offering the thermal cure HYDAC, we're able to coat the inner diameter of your projects as well. So in considering a hydrophilic coating provider, here are some factors to consider. Experience in your substrate and market application. Proven performance in the areas of lubricity, durability, and particle count. A dedicated development and support team to help you and your engineering team with your projects and your hydrophilic coating for those projects. And also support of your product sales and production, both through contract coating services, but also in the area I spoke of earlier, in development of machines for your unique products if you choose to bring the coating production in-house. And flexibility. Biocoat offers a variety of different types of business models to suit your need, and also how we can deliver coating to you as well. So at this point in time, I'd like to turn it over to Dr. Bob Hergenrother, who will take you through the more detailed information around our coatings.
Well, thank you, Jim. So when you come to Biocoat, we want to understand your needs and requirements. So we'll have a discussion to understand your performance requirements, such as Jim mentioned, about lubricity, durability, and particulates. Your sterilization process, whether that's ETO, it's gamma, or it's E-beam, and where you want the coating applied in terms of the length of the coating, as well as the inside or the outside diameters of those devices. Material choices can influence the coating performance, and I'll get into that in a little bit more in detail. And then finally, do you have a preference for a curing method? If that is, if you have machines at your facility already have a certain type of either thermal or UV coating, or on the, if you're doing ID coating, typically a thermal machine is a better way to go. So some of the key considerations for a successful coating. Clearly, there's the material choice, that there is usually not just one material, but multiple materials that are made up this device. Finding out how all those are being put together and having that you have a good coating that applies to all of those. The other part for this is on materials that are added into sometimes the extrusions to aid that, or there can be other oils or contaminants that can cause problems for coating adhesions and that will need to be cleaned off. In fact, I would say that other surface modifications, such as PTFE, which is Teflon, or silicone in a mold release or oil, can also interfere with the adhesion and can inhibit that coating performance. So we'll want to understand all of these, make sure that we can clean this and have a well-designed and robust coating process before you get into that, your design freeze and reproducibility. The other part of this is that plays in on considerations is accelerated aging plans that can determine the coating selection. And I'd even say on the selection of the materials and making sure you've got the right stabilization additives into those materials. Now we can coat a variety of substrates, both plastic and metals. So the plastics, we go anything from the very hard materials such as your nylons or your hard P-baxes down to very soft P-baxes, other polyurethanes. And in metals, the sort of the workhorse metals of stainless steel, nitinol, and titanium, to the precious metal ones like platinum and gold. In all these cases, we apply a base layer that primes that substrate and normalizes the surface to make it very receptive to our hydrophilic top coat. We apply the base layer onto that substrate and then dry it and then cure it with either heat or UV light, depending on the chemistry that we're using. After that has been cured, then we apply a hydrophilic top coat, again, drying it and then curing it so that you get a very tenacious, durable bond between the hydrophilic top coat to the base coat and down to the substrate that allows you to have a very high performance coating. And as we stated before, that the substrates and surface contaminants can really interfere with that coating adhesion. I want to emphasize making sure we understand what those are, and even before we apply the coating, make sure we have a good cleaning process for your device. Now let's take a look at how Biocoat's HYDAC coating performs on actual commercial devices. And in this example, we acquired 6 different neurovascular microcatheters. 2 of them had Biocoat's coating on them, and 4 others had different coatings. But we put them through the same coating characterization of looking at lubricity and durability by a vertical pinch method. We did particulate testing by a tortuous path and measuring the particles with light obscuration, and then also actually visualize some of those particles by either a toluidine blue or Congo red, depending on the coating that we used. So before we get into the data, I'd like to talk a little bit about the particulate evaluation and that it's an evolving area of regulatory interest. Regulatory agencies are asking for test results and justification for the levels of particulate from coated devices. The challenge for everyone is that there are multiple factors that can contribute to particulate generation. There are standards and guidance documents for coatings from agencies such as FDA, USP, ASTM, AAMI. However, none of these are entirely applicable for particulates generated from medical devices. So with that in mind, here's how we test particulates at Biocoat. And we use a very aggressive test to really differentiate between these coatings. So in our parameters to the test pathway, which obviously needs to be clinically relevant, shown down below for what we used in this test, but that will vary by device and application for your particular application. The duration of the test, we're cycling the catheter through this pathway 50 times, flushing after every 10 cycles. And then there's simple things like the sample container, the flush solution that need to be defined that can make a difference in terms of how those particles, whether they stay in that solution or absorb onto the vessel wall that you're containing it. and even the time to measurement. At Biocoat, we take the container that has the liquid and move it immediately to the white obscuration particle detector that we have to count the particles. As you can see, there are a lot of moving parts on a particulate measurements, and so the key is to get help to ensure your device is within regulatory requirements. And I'm happy to talk to you about that as you're working with us or other experts that have worked on particulate testing and submitting it to regulatory agencies. So now let's look at the performance of the HYDAC coating relative to some of the other coatings that were on microcatheters. And what we've done here is on the graph on the left is to look at the lubricity and durability through a vertical pinch test, where in this case, what we take is two rubber pads, squeezing the catheter together between them at 470 grams of force in PBS, and cycling that up and down at 37 degrees C for 30 cycles. And in this case, what you can see is that first bar on each of these samples shows the initial lubricity of the device and gives the value of that at average over the first 3 cycles. And then the durability is shown by the 30th cycle. Ideally, you would want a catheter in the coating that does not change between that first cycle and the 30th cycle. And if it loses durability, it can increase over time of that friction. And what we've shown here is on NC1 and 2 are the two devices that had the Biocoat coating. They were applied at the manufacturer's facility, but using our coating. And then there's 4 other ones, NCs 3, 4, 5, and 6, that used other different coatings. And you can see here that on all of them have some good initial lubricity, around 5 to 10 grams in pretty much all cases. What's interesting is on number 6 shows an example of poor durability, where over time that coating started wearing off and the friction went up. And this can manifest itself in clinical cases that the catheter is harder to push and advance into the neurovasculature. I've also included our new UV coating. While it's not on a microcatheter, by coating tubing, we've shown that it meets that same level of performance of the lubricity and durability that we've seen on our other ones. So this is the lubricity and durability and primarily how coatings were evaluated up until the particulates got thrown into the mix. And if you take a look at the graph on the right, there's the particle counts. And what we've done here is all particles greater than 10 microns, all the devices, total number coming off of each device, were counted. And you can see a very different picture of the performance, that there is a 20-fold difference in the number of particles that are generated between the very low ones, which happen to be the Biocoat coating ones, to the NC6, which had 33,000 particles. Now, for that one, of course, that didn't have as good of a durability, so you may expect that to have a higher number of particles. But neglecting that one and setting it aside, looking at numbers 1 through 5, where it had basically the same lubricity and durability, there's a 10-fold difference in the particles. So this gives another dimension on how to evaluate your performance and how you want to optimize low friction, good durability, and low particulate formulation. And what this means to you is that you get a coating with high performance in all 3 aspects of that lubricity, durability, and particulates. Finally, I want to show a little bit about the images that we've come from the particles coming off of these devices. And not all particles are the same. You can see that there's some different morphologies of these. The picture on the left is showing low particulate coating, where the particles were very small, actually kind of hard to find, and were small and round. In contrast, some of these higher particulate coatings, not only do we see some of these small round particles, but some more ribbon-like structures of that, like the coating was stripped off in long strips, almost, half millimeter or longer strips of the coating. And so this is another aspect of that, and it shows actually counting the higher, larger particles is also critical for understanding the coating performance. And to be clear, we're just looking at the hydrophilic coatings. But there's a new paper from some Mayo Clinic researchers that when they examined the extracted clots from an aspiration catheter, over half of those extracted clots had foreign material in them. And what was really interesting is that over 90% of those foreign material was PTFE versus about 30% of those cloths had hydrophilic coating material. So this emphasizes not only about when you're designing your device, not just the coating, but all the materials that are going into your device, as well as everything going into that procedure to understand really the makeup of the particulates. And now hand it back off to Jim to talk about some of the coating reagent performance.
Thank you, Bob. I appreciate you going through that information. I think that starts to demonstrate really scientifically the differences between coatings and how important it is for the coating to be best in class in lubricity, durability, and as you had mentioned, particulates as well. I'd like to take the next few minutes to just talk about coating production and some of the services that are available with Biocoat. From a coating production perspective, I mentioned before that we are an ISO certified manufacturing process facility. We also have FDA master files available on both a thermal cure HYDAC as well as UV cure HYDAC. In addition, we deliver coatings via reagent delivery, which means that we would make the reagents and send them to you, and you could utilize those to coat them on site at your facility, or we offer contract coating services if you don't have that opportunity available. In addition, talking a little bit more about the contract coating services, what you see on the right are the two types of machines that we have. The one on the top is the thermal cure system, and the one on bottom is an inline UV cure system. But the purpose of us adding coating services here at Biocoat is to make sure you have a seamless coating application opportunity for your devices. We have developed this under a CGMP environment, and we have a stable, repeatable application process. And the goal is to fulfill all your needs from a coating perspective for your medical devices. We have rapid and efficient turnaround times, which we know is important because of your burn rates and the things that you're looking to do, and getting those products back to you, final packaging and sterilization so that you can then commercialize them. And as I mentioned before, but I'll mention it again, we offer best-in-class customer service, where you have a one-on-one relationship with an internal engineer and a team that can help you through the process, making sure your devices are coated to the highest quality standard. We also offer a turnkey coating machine design and delivery option. I mentioned that we were launching this in 2022, and we are getting ready to roll that out right now. And we offer build options for both the UV cure systems as well as thermal cure systems. And we do it for both an R&D level machines or commercial level production for your products. And they're really built for your specifications and requirements. So we work with you specifically to make sure that we're meeting all the requirements that you have on your end. And as I mentioned before, our goal is to be on time with our delivery, on time so you can keep your projects moving forward and on budget as well. I want to make sure that we're meeting the highest quality standards. So in summary, at Biocoat, we offer you vertical integration and flexibility. What you see here on the left is what Bob had taken you through. We offer both thermal cure, hydrophilic coatings, as well as UV cure, hydrophilic coatings. And from a delivery option perspective, we offer a contract coating service in-house here at Biocoat. And we also offer you the opportunity to license the reagents and have them coated at your facility with your systems. Either way, Biocoat is committed to customizing a business model to meet your needs. So in summary, why choose Biocoat? First and foremost, we are completely focused on coatings development. We're not trying to be something that we're not. As Dr. Hergenrother had gone through, we have proven best-in-class performance. Our goal is to partner with you and your products for your success, because if you're not successful, then Biocoat is not successful. Rapid turnaround times, so you get the information back to make changes and advancements in your designs until you lock in that product for hydrophilic coatings. Different pricing models to meet your business needs, and high-touch customer service, of course, to support your project. So as we like to say here at Biocoat, we don't want you to just coat it, we want you to Biocoat it. But if I may, I want to offer one more suggestion, and that is please don't wait. When you think about hydrophilic coatings, it's usually towards the end of your development process. But the sooner you're able to send us materials, the sooner we're able to help you to tune in the performance standards that you're looking for on your final medical device. So please don't wait. Send us, even if they're R&D level pieces of material. We can work with our application development engineers to start the advancement of the hydrophilic coating process so we can dial it in. So when you're ready to start commercializing, the hydrophilic coating is finalized and ready for you to go. So thank you again for your attention. I wanted to also ask if there are any questions from the audience, and I'll leave this up for the, if you wanted to learn more about our coatings, you can contact us at these two email addresses. One's at biocoat.com/resources/ or send us a message at sales@biocoat.com, and we will follow up with you within 24 hours. Thank you for your attention, and I'll look forward to answering the questions that come in. Okay, we have a first question that has come in. So I'll read the question and either Dr. Hergerother or myself will answer it. So the first question is, what makes Biocoat the leading coatings provider? Well, Bob, if you don't mind, I'll start this and you can certainly add in your comments as well. Is that okay?
Sure.
Okay. So as we mentioned, Biocoat is one of the only companies in the world that really offers the two unique options of both a UV cure and a thermal cure coating. In addition to that, we also are able to offer you the coating services in both of those technologies as well. A second important point is, as Dr. Hergerother went through, we have best-in-class performance. And that's really what's important to you all, I would assume, is that you want to make sure you've got the best hydrophilic coating to help your product do what it's supposed to do and do what it's designed to do. But also an interesting point that I want to make is our goal as an organization is not to compete with you. We are staying vertically integrated to a certain point in the process. And that point ends with us looking at machine development, and coating services. We have no intention to move into creating devices that may compete with you in the marketplace. We also are very focused on customer service. We want to make sure that we're giving you the highest level and highest touch customer service. And from a capabilities perspective, oftentimes when I'm in the field talking to customers, one of the things that's a bit of a surprise to folks is our ability to coat metals. I'll let Bob talk a little bit more about that in a second, but that's certainly an opportunity that we see that's unique with Biocoat. And of course, with thermal cure, the ability to coat the inner diameter. Bob, maybe you want to talk just a little bit more about the coating of metals and what your experience has been.
Sure, Jim. Yeah, I'll add a little bit more to that. On the metals, what differentiates us from some of the other coatings is I'd gone through our two-layer coating process. Our base layer bonds just as well and coats just as well to metals as to the plastics. So as a result, you don't have to add on a third layer that some other coatings require for priming a metal. And so as a result, you can just buy the same coatings from us for both your plastic pieces and your metal pieces, and they'll work exactly the same.
Great, thanks, Bob. Appreciate that. So second question has come in, so I'll read that question, and maybe Bob, you can take this one to get started. So the question is, what are the future trends that coating companies are looking into?
Sure, I'll take this, Jim. And I think it's an excellent question in terms of looking into the future. And what I've seen is, and what we've seen is, there are a lot now of these devices go into these multi-durometers, many different segments, and having some very soft segments at the distal end to make them very atraumatic for the vessels. What the challenge that can be is to make sure you have a coating that works on all of those different segments. And so we at Biocoat have been working very hard to make sure that it covers anything from like a 25D softness to even lower to up to those hard nylons. The other part of this is, I'll say that we're seeing, Jim had mentioned about the ID coating capability. We're getting more interest in coating the ID of that lumen, especially at that distal end. And with our thermal system, it allows us to coat this exceptionally well and do that in conjunction with coating the outside at the same time. And even with all this, devices are getting smaller and smaller. All these minimally invasive devices, minimizing that puncture that's going into the body, shrinking them down more, but then maximizing the OD of maximizing the ID of the device to kind of put your implant through there, and then minimizing the OD. And all of this can create some challenges on thinner walls, the braiding, but we're seeing all that, and I think that will continue into the future.
Yeah, I think that's great, Bob. Thanks for bringing that up. And I'll reiterate what you said prior in the question. Not only are we seeing the trends in softer durometers and our ability to coat it, but we're also, again, able to use that same type of formulation to coat the metals as well, because we're seeing a lot more on the metal side with nitinol and different types of products there as well. So thank you for that. We have one more question that's come in. This question is, does Biocoat develop our own devices? Bob, I'll take this one if you don't mind. I mentioned in the first question that we have no intention of going into manufacturing of devices. We know that some other companies have made strategic choices to do so. And since I've been here almost 4 years and working with our ownership, we've made a strategic decision that we will not go into the business of manufacturing of devices that compete directly with our customers. We are very focused on what we've gone through here today, which is vertically integrating to a certain point. We believe that we have best-in-class hydrophilic coatings, not only in the thermal cure, but also now in the UV cure areas. We offer best-in-class services from a coating perspective, where we can actually not only design the material for you, but also do the coating of your medical devices for you. And then the next step, of course, is being able to have machines available for you should you choose to take it in-house. And that's where we're launching that in 2022. We'll be launching partnerships with several different machine development houses to allow us to vertically integrate to that certain point. So for you, as you're looking at your hydrophilic coating front to back, Biocoat can be the company that can do all of it. We can offer you all the technical support that you need, the high-touch customer service through our engineers and our research development teams, with Dr. Hergerother and Bob's support, as well as taking you all the way through to creating a machine for you if you choose to bring that in-house. But all of it will be done in a best-in-class way, high quality, and making sure that we're meeting your needs in the marketplace and for your company. We know that Biocoat, that we are a guest in your business, and as such, we have to earn your trust every day, and we firmly intend to do that. Bob, I don't know if there's anything else that you wanted to add to that.
No, I think that covers it, but we are exclusively focused on making the best coating for your devices we possibly can.
Great. Thank you, Bob. I wanted to thank you all for your attention today. We appreciate you joining us here for this Biocoat webinar. Again, up on the screen, you see that there's 2 resources that you can send us a message, and we'll get back to you if you have any additional questions. I wanted to thank you for the questions that did come in, and we hope that you enjoyed this session with Biocoat. Thank you very much, and have a good day.